Welcome, everybody. Today's presentation on locally modified wheelchairs will be presented by John Zoe, who is the clinical engineer at the Upper West Regional Hospital in Ghana. And now I'll turn it over to John. Over to you. Thank you.
All right. Thank you so much, Bill. Good evening to everyone, fellow colleagues, and thank you, Ghana Medical Health, for this opportunity to showcase the simple things we are doing at our various hospitals, so others can also learn from it. This is our presentation, locally modified wheelchairs for improved maintainability and sustainability in Ghana. And then, of course, as Bill introduced, presented by John Insor, I'm a clinical engineer at the Upper West Regional Hospital, and I'm doing it on the platform of Ghana Medical Health. Now, this project seeks to find a solution to some of the problems we face in this country. Usually we have an issue in terms of access to durable mobility devices, then the frequent breakdowns of the wheelchairs that we have that go a long way to affect patient mobility and independence at our various hospitals. Then there's a need for sustainable and local maintainable solution to some of the problems that we face, especially with respect to the wheelchairs. Now, what are some of the challenges? There are frequent wheelchair breakdowns at our various facilities. If you look at the pictures here, the pictures shown, you realize that the tie is broken. The solid tie is broken into pieces, shattered into pieces as shown in the picture. Another issue is the spokes. Due to the load, sometimes the spokes snaps out of the holes, making it difficult to move freely on the floor. Then these ties are not available to buy, usually in our local market. The closest you can get them, you have to import, which takes a lot of time. Another issue is a poor terrain. Looking at our various facilities, from sometimes linking, you have to pass through a rough terrain. And as such, wheelchairs are not able to cope up. And the weather too in the northern part of Ghana is also sometimes a factor because it can go as high as even 40+ degrees. So that sometimes responsible for the ties being dried up and becomes hard and then breaks into pieces like this. Now, what are some of the problems with the existing ones? Of course, the spoke break is another issue, usually under heavy load. When the load is beyond it, then it snaps out of the holes. And sometimes the rim will bend due to, of course, the same load and on the rough terrain. So as you keep on pushing the wheelchair on those rough terrains, the rim do bend, making movement difficult. The ties will wear out. And then there are also a problem with, in terms of the wheel hook misalignment. Usually do not align well, all as a result sometimes to the load. Now, what do we seek to do? We want to redesign these wheelchairs so that we can use them for a long time. Then to make use of locally available spare parts and to be able to reduce the maintenance downtime as we get the materials from the local market. So technically we'll be able to reduce the downtime instead of the long process of importing the parts to fix such a local problem. That could take sometimes the minimum of 3 weeks. Then again, to improve the terrain adaptability. What can we do to adapt to our local terrain so we can use our wheelchairs here? Now, this is our key modification. So we replaced the entire wheel system, the spokes, instead of using the spokes, we use a solid wheel that do not require spokes. We also use a solid tie, the solid or inflatable tie. So in this case, we are using the inflatable ones. Subsequently, we see the reason why we prefer the inflatable. One reason being that it will serve as a shock absorption. As we move through the rough terrain, it will absorb the shock without transferring the shock onto the patient. Then we will also reinforce the wheel system in order to be able to accommodate this big tie or big wheel for that matter. So to do that, we also have to improve the axle alignment. We have to look for a more robust axle in order to be able to fit into the big wheel. So with this, the spoke wheel replaced with the mud or solid rims. We have replaced the whole of this. This is what we are talking of. We replace the entire wheel system. Why are we doing that? So that to be able to bear a heavy load, the load capacity that it can take. First of all, when you do it as engineers, you can do stress analysis. So in your stress analysis as an engineer, you can subject it to all manner of terrain, all manner of load. For example, when I was doing it on the software, so what I did was that I tried as high as 1,000 kilograms. That's 1 ton of a human being. To see at what point would the current wheel will either deform or fail. So that's the easiest way to do the stress analysis before you can conclude on what to do. And if you also look at this wheel, it's quite bigger than what we use. Then there's a reason for that too. I will get to that very soon. Of course, so after we have done that, the issues related to these spokes failure will reduce or will be totally eliminated because this we will not be using spokes. Then improve durability. Of course, as we do this, it will last longer since the spokes will not be there. It's able to bear the load. So why do we use this kind of tie, quite big like this? And then it's inflatable. We inflate it through this side. We do that because this tie, due to the area it occupies, it serves as a better shock absorption. With a tie inside, the tube inside it, when you inflate it very well, it is able to absorb the shock. Unlike the previous one, whenever you push it through the rough terrain, depending on the condition of the patient, you see that the patient will be crying. Why? Because the rough terrain is shaking the patient, and based on the condition, he or she feels some pains. So whilst we have used this big one, it will help improve what? Comfort to the user, then enhance performance on rough terrain. And of course, these are locally available that we can easily replace. Now, to make it possible, then we have to enlarge this wheel system, this U-shaped metal that we added onto the already existing wheelchair. The old wheelchair is these portions, including the handles and all that. What we did is just making this U-shaped metal, weld it to the already existing one to be able to accommodate the current wheel. So once we do that, it will help improve the frame stability. The frame we use in it will make it more stable. Of course, we weld the steel in order to be able to support that. Then this will help us to reduce the misalignment issue. So once we have done that in terms of the seat and the wheel, then the front side where the patient is supposed to put the foot or the feet, then we made the flat metal where the patient sits, then rest all the foot on that, a little elevated from the ground. Then with this, will help improve the load support because the legs of the patient will sit on this flat plate. So for that matter, this will also help reduce the bending and the cracking. And in the long run, enhance user safety. Now, we made some comparison here. For the spokes, due to the original one, the spokes fail. For our modified one, we totally eliminated that because ours will not use spokes or doesn't use spokes. And when we come to the component in terms of the spare parts, we have to import them. I don't know any local company in Ghana here that manufacture, those parts. And even with that, they are not readily available. But in terms of our modified ones, we have them available because we have a local scooters that are in town and which are popularly called Mahama Kandu, and they are means of transport. So for that matter, their tires are readily available, unlike the original wheelchairs. Then in terms of their terrain performance, we realize that the original one has poor performance. Of course, you should understand where these wheelchairs are made. If you look at some of the movies in the Western world, see the hospitals from one unit to another, you see that there's terrazzo and all that made the place smooth. So you can easily push the wheelchair around. But the same situation cannot be related to ours. Because ours, from linking from one wall to another, sometimes requires you to push it through a rough terrain. And for that matter, with this new type that we are using, it will improve the performance on the terrain. The repair time, of course, I made mention of that, how to come by them. In Ghana, it's very rare to get them, especially the solid ties. And when you now come to the north, it's even absolutely not easy to come by them. Then the cost. Of course, importation cost is high. But with this, it's reduced because they are the local market. So you hardly need a transportation cost in terms of this. It's a matter of moving to town and you get one. Now, I made mention at the beginning, why do we need to do this? The WHO gave its guidelines in terms of wheelchairs. That was written in 2008, and then some few years ago, it was updated. And what were their recommendations? That wheelchairs must be appropriate to the environment. Unfortunately, we don't manufacture the wheelchairs, but we have an environment. So we have to make it appropriate to our environment. Then their recommendation is that it should also be durable for terrain and should be able to be repaired locally repairable. That were some of the recommendations. And the spare parts must be accessible. The ISPO, International Society for Prosthetics and Orthotics, they also emphasize that the wheelchairs will meet a context specific in terms of the design. What it means is that in our society, in our case, any wheelchair that we need to use in our Upper West Regional Hospital or in this part of the country, it should be able to, the design should be able to be to meet the specific needs of Upper West Regional Hospital or for that matter, Northern Ghana or Ghana in general. Then it should be able to also be acceptable or being able to be used in terms of a low income settings, our part of the country. But usually these designs are usually ignoring this aspect, because later on we will see that 40 to 70% of the medical equipment donated to sub-Saharan Africa, of which Ghana is a part, are usually broken down. Already they are not even in good condition before they are donated. And most of these donated, the main medical equipment there is the wheelchairs. And if you go to the garage of most of the hospitals in this country, the commonly seen broken down medical equipment is a wheelchair. The ISP also emphasized the maintainability as a key design criteria. Now, this was an article written by Hazelwood. Then they did it for engineering for global development. So they emphasize that equipment in low resource settings in our part of the world or low middle income countries must prioritize simplicity, maintainability, and local part substitution, of which this is where we are interested. Local part substitution. Now, Hodgwick and all, they too also wrote to global health technology. In fact, they did the research and in East Africa, Ethiopia, and the rest. So they realized that 40 to 70% of the medical devices in low middle income countries fail due to lack of maintenance and spare parts. And nice medical equipment that has been donated from the Western world, what is the issue? We cannot come by the spare parts. And we have them at our facilities, a lot of medical equipment. We have some analyzers from Italy. They are broken down. What's the problem? We cannot come by their spare parts. They're not even available. And sometimes those that you get, probably the machine is no longer in service. So usually those companies don't produce those spare parts again. So based on their research, this is what they discovered: 40 to 70% of the medical equipment. What it means that any container coming to Ghana with medical equipment, and when they are removed to use, within a year time, when you come back, 40 to 70% of them cannot be used. What is the issue? The spare parts are not there. So in that paper, they also concluded that local adaptation improves sustainability. Whatever you do, it should be adapted to the local so that the sustainability can last. Now, what is the impact of this project? It promotes proactive engineering solutions. Then it encourages local innovation, reduce dependence on imported parts. This is a matter of getting to town, get your wheel, come and replace it. Then improve hospital equipment sustainability. As we do it, now we keep on having, so mostly we have taken our headache off the wheelchairs because of that little improvement we have done to these original wheelchairs. Of course, the material that we are using for all this improvement can be found in our local market. And usually now we are even working with a local artisan, of which if we even do the design, give it to him, show him what to do, even the mere fact of showing him the diagram, he will be able to modify, and he has been doing that. So when Hoodie's medical director came to our facility and saw it, and I was contacted about it. I just linked them to the guy we've been contacting to do the welding, and I'm sure he was able to produce some for them. Why are we doing this? For lower long-term maintenance costs. All the time, if we have to keep on buying due to our terrain and they're breaking down, the cost will go high. So with these locally available materials, of course, the maintenance cost, the initial cost must be high because this tie is a little expensive. But if you do that, then the long term, you have reduced cost. Because next, what we need to do is always inflate it. If the tie happen to lose pressure, then you inflate it. Of course, if you're able to do that, you should be able to support local artisans and technicians because it's now become a source of income to him. Because any hospital management that happen to come to our facility then see it, they say, okay, then we can do same. So usually when they contact us, then we link them up to them. It's a solution we are looking at. So we link to them and then they will also provide for them. So our locally modified one improves durability. Then our maintenance, of course, it becomes faster and more affordable. You don't have to wait for a long time, go and pack it somewhere. Sometimes they're wondering whether we are doing any work. They say, oh, this wheelchair is broken until now, you cannot do anything about it. But with this, the moment when there's a breakdown, it's a matter of procuring the parts and then you can fix it. In fact, with this, you can easily even get the parts, come and fix it up once the documentation and the procurement process can go on. Yes, but if your facility even having an upper hand, you can procure the wheels a lot and then use it. I forgot to add, the wheel is quite shorter than the original one. Yes, because this will make it more stable on the road. In physics, the higher the body from the ground, the less stable it becomes. And the lower it is to the ground, like a sports car, the more stable it is on the road. So this, in the long run, will enhance mobility and quality of life of our patients. And then, of course, it becomes a sustainable engineering solution for this country. So thanks to Ghana Medical Health, of course, giving us the platform. Then our team at the Upper West Regional Hospital. Then the hospital management and then that of the estate unit. Of course, this is a man we have given the wheelchairs to him, Alaji. He does that all the time. These are our references. And now this is how I want us to take. As clinical engineers in Ghana, our responsibility is not just to maintain equipment, but to adapt technology to our environment. Thank you to you all. Bill, over to you.
Thank you, John. A brilliant presentation. Raised many important points about equipment in low resource or middle income countries. And we will open the floor for questions. I see Martin has his hand up. Need to unmute yourself, Martin.
Yeah, thank you. Yeah, fabulous, John. I saw, as you know, I saw one of these wheelchairs when I was in, I can't remember where I was.
Yes, Wild West.
Yeah, we shall. Yeah, thank you. Where was I? No, I think it's just a fabulous modification. Just a question: how well are the welds holding up? Are they have they been breaking, or are they've been okay?
Oh, you're welcome.
Oh, for now, we are okay with them. The only issue sometimes I observe, of which we will be looking at, it's actually the front one. We realize that the front wheel, we have not replaced that one. That's the original one. So mostly, if you come and see them failing, it is this wheel, the front one, that is the original one that sometimes fails.
Okay. Because I was just looking, I was looking at the design, and I was thinking to increase the rigidity of the wheel on the axle, just to make the axle go all the way across between both wheels. But that was my
Okay.
But that just to help with the so that U-bar doesn't flex back and forth as much. And but if you're not having any problems with the welds, then that's just great.
Okay.
I see Ebenezer, you have your hand up? You need to unmute.
Yeah. All right, that's a nice presentation.
Thank you.
Yeah, but then I just need some clarification here, perhaps. If you compare this one to the original one, I don't know. I heard you say, I heard you talking about comfortability. I don't know. Did you say something like that?
Yes.
Is it in terms of, let's say, let me use this typical example. Let's say from the seat to the floor.
Let me
If you look at that,
let me show you what I am referring. If you look at this tire, what it means that it's able to absorb the shock compared to the previous one, the long wheel. I don't know if you're getting
okay, so yeah. Okay,
because
so the question here,
the original one, you don't inflate them, but this one you inflate it. As the tire moves in the ground, due to the load, you see that because the pressure in the tube, it helps in the shock absorption compared to the solid tires. So that's what I was talking of in terms of the comfortability.
Okay, I'm even talking about the size of it. You know, normally I think the reasons for those long wheels or larger wheels in terms of height is to provide enough. Let me borrow this word, ground clearance, like from the seat to the floor, so that if someone is tall, perhaps, and the person sits on it, he doesn't need to, like, though the legs will be folded in a way, but then there'll be some little bit of comfort when it comes to that. But then now, if we use this short one, I see, or to me, I see that perhaps maybe those people who have height, the tall ones, will probably suffer when they sit on it, talking about their legs.
Okay.
So I don't know whether we can look at that one too.
What I might think based on what you are saying in terms of the reason would rather be the user or the one pushing the wheelchair, because this one has gone down compared to that one. But in terms of the patient seat and everything, there are nothing has changed in that regard. The only thing that has changed almost getting to the end is the footrest. But the seat and everything in terms of the size and then how it is, nothing changed that side. It's only the wheel that has been brought a little lower, in the sense that as it comes lower, it becomes stable on the road compared to when it's high. You see that sports cars are lower. So with that, they are more, stable on the road compared to when it's high.
Yeah,
Why
I think
because in the pushing, the one pushing, because the tire is big, and pressure is inversely proportional to area. So the larger the area, the more force you require to push it. So that's the main reason why usually we don't put even brakes in the handle, because of the tire. So as you are moving smoothly on the.
All right, so Senior, I think I understand the point too. But like I was saying earlier on, you said wasn't in this new tie compared to the old one. This one is more or less like shorter. I'm using the
Yes.
I'm looking at it in terms of height, right?
Yes. Yes, please.
Good. And I'm saying that once it's shorter, it means you've reduced the seat to the floor clearance. You've reduced it as well. Anyway, you look at it. That is it. And then the other question is this, or the other observation is this. If you look at, you said this one, you need to, it uses air, right? You need to pump it, right?
Yes.
So I think if you look at the original wheelchairs too, there's a reason. There's a reason why they don't use, let me see, the tubes, the one that has tubes inside. Maybe they could, and so some of the reasons are what's the name? Needles and other stuffs, sharp objects that you find in the ward or the hospital premises. So with this one, yes, even though it's thick enough, but then it means maybe one way or the other.
Sorry.
Did we consider that one too?
Yes, some of this they usually come with the fluid. There's a fluid that the guys will introduce into it. In an event where there's puncture, it goes to seal that place. And that's why we are not totally discounting why they use this one, because their terrain, it is okay to use those ones. But in our case, where we have to push through a rough ground, those ties are not helping. So that's how come we went for this. And besides, there's a flute. I can't come with a name that the guys usually introduce into it. In an event where there's a puncture, that flute goes to seal the place and then stop the leakage. Then we have the pump, the one they use to inflate the tires available. Whenever it goes down, it's a matter of taking it there and then inflate it. So these are the things that we factor into that.
Okay.
John Ziena, you have your hand up.
You know that.
Yes, I think my concerns were just bordering on what Ebenezer has raised. But
okay.
Yes, and it's a great innovative work which should be commended. Where we need to make suggestions for going forward to improve the innovative works. The height issue that Ebenezer brought about, which I also wanted to comment on, I think what we need to do is, going forward, if you are putting these ties that are narrower than the original ties, then maybe we need to raise the members with the U-shape or the U-clip, for example. You should also consider, if you are going to make the U-clip, which is hooked onto the tie, maybe you should do some measurement for it to move or to be about the same dimension with the original tie, so that you could have a taller person pushing the wheelchair while the patient is sitting on it. If that person is tall, they may have to bend and push the wheelchair. If the person is of average height, maybe it will help. But if the person is very tall person, they may be suffering to push because the height has been reduced somehow. But to still put it about the same height with the original wheelchair, I mean the original wheel, then maybe we need to increase the height of the U metal. That is, clamp onto the wheel, so that at least the height can be adjusted to meet other people's who are taller enough, so that they can also push the patient comfortably. The other thing, probably I will also look at this, as Ebenezer also mentioned, this is very innovative. There's nothing wrong with that. Probably the other reason why they may use slimmer ties originally is to reduce weight. When you are pushing the patient might be heavy. So they put slimmer ties also to reduce weight. These ones probably can add a bit of weight to the wheelchair in the, as the patient as well. But going forward, all these things can be looked at further. It is something that we have to look at, and then going forward, improvement can be made. These chairs, these ties are okay. They are solid enough. They are robust to support patients. I recommend that you can continuously using them, with the exception that the height will be adjusted a bit so that taller people can also push without any problem. Now, the other thing I'm looking at is the front tie. The front tie might not be matching very much with the back tie. What are you going to do, for example, to also redesign the front tie? I don't know. That is still smaller than the back one. I don't know whether you have had any issues matching the two. Maybe we need to know that.
In fact, it's measured in line with the front one, because the front one, that's even the original one.
Okay.
But the only issue
Yeah,
we
that's
now
the
have
original
with
one.
yes, the front ones are just the original that came with the wheelchair.
Okay.
But one thing I realized that due to how we put our entrance, the door entrance to some of the wards, as they push the patient there and they need to, so when they push it hard and sometimes they have to hit it hard, and if you take time, you can push the patient forward because of that tie. So most of those that are filled is because of those ties. So I'm thinking of putting two small casters, one in front, one at the back, where when you get to that place, it will be able to climb, because the small caster is easy to climb. I don't know, you understand what I'm talking about? The door.
Yes, I do, yeah.
Sure. Our door, the ground of that one is different from either the inside and the outside.
Yeah.
So you overcome it. So, but the back tie climbs it easily, but the front tie is difficult to climb. So if you see most of those that are currently broken with this one, it is because of that front tie.
Yeah.
So I'm thinking of using a small caster, because the small casters are easy to climb on that one than this original wheel. So basically the failure is out of that wheel that we are experiencing these days.
Okay. So this ties in very well with the neglected piece of equipment that I'm preparing to talk about. This is one of them. I don't know what, that is one of them. There are other ones that during the discussion we will look at them. But it's a great job. It's a great job, because if we go on with this kind of innovative work, we bring out a lot of these pieces of equipment that are usually neglected and packed somewhere. While we keep on buying them, they come within a short time, they are broken down, we pack them, and then we keep on going through the same cycles. Thank you very much. Well done.
Another thing that I need to mention is that, this country, they passed what we call the Disability Act, expecting that every public building should be modified to accommodate some of this. So if you look at our place where the story building is, if you are pushing a patient from the ground all the way up to that level, so usually with the tie, in the process, they break down. But with these big ones, in fact, it's easy to push them out to that long route all the way up to other medical ward, depending on the level the patient is going.
Okay, John, just a moment. Let me also add this piece of information. The U clip that you have made to mount on the tie, for example, I don't know the material. Is it the stainless steel material, or is my steel or galvanized steel? I don't know. And of course, the ties, the rims I believe are steel rims.
Yes.
And these wheelchairs, the purpose. to convey patients from one side to the other. And then in the process of doing that, you may have them contaminated, the wheels, and then so we look at how to prevent contamination. Now, if these metals that are U-shaped, I think most of the time, the wheelchairs members are stainless steel.
Yes.
Yeah. I mean,
Yes.
for corrosion resistant, because
Yes.
even in the walls, some chemicals may pour onto, or sometimes when they are even healing the patients, they may carry some medicines and things like that, and they spill on the frame.
Okay.
And they use this resistive materials in order to, protect the frame of the wheelchair. So maybe we also have to look at the materials. Even if you use mild steel or galvanized steel, you should be able to use some coating that can resist corrosive, materials, patient-based fluids and things like that. So that going forward, we can make sure that, or the rims, for example, because they are steel.
Engineer, not to cut you short.
Yeah.
Engineer,
Yes, sir.
they are galvanized steel, but they are galvanized steel, which are oil sprayed.
Okay.
It covers for the aspect of rust. So for us, we wouldn't have a
Rust.
problem. The whole thing after it was done was oil sprayed.
Okay.
So we don't have
So
rust.
just a suggestion. Once one that has been done, that's okay. Okay, well done.
I have a question. John, you talk about lowering the center of gravity of the wheelchair because these are smaller wheels. Does that mean, it's not clear from the pictures, does that mean that the seat of the chair is actually sloping backwards towards the rear wheels because they're now lower to the ground, or is the seat still level somehow?
No, it's still level because if you look at this, there's already a horizontal bar. I don't know, you can see this bar linking the front wheel of the back. So to lift it, it's high. If you pull it up, the whole chair goes lower. The welding is done at this junction, these portions. So if you detach this and push it up, then you are bringing it down. If you take this one, then push it up, push the whole rim, you see that there's still a space between the wheel and that of this. So if you take this up and pull it down, what it means that you are pulling the whole rim going down. So where the seat is, it will be up. But when you detach it and push it up, then the whole chair comes down. So it's in line with this. There's already a horizontal bar linking the back to the wheel, the front one. So it's a matter of raising this to make it horizontal with the front one. So it will not be lower than the front one. And I think that even when it's rather lower than the front one, it's easy for the front one to climb better.
Yes.
But I think if it's lower, so it's something that we need to look at. So if it's lower rather than the front one, I think it will be easier for the front one to climb. So usually the failures are due to the front tires now. That is the problem.
Thank you. John, you have your hand up again.
Yes, I was just looking at let's look at the front, the foot support. Can we look at the picture of the frame that is supporting the patient's feet?
I think, yes, that's what I'm showing right now. I don't know, you can see it. I'm using my cursor on it. Okay, so
yeah.
this is a plate.
That's the plate.
That's the plate.
Can you zoom in a bit? So this particular wheelchair, is it foldable?
John
Is it
So's-
is it a foldable type? Is it foldable?
Exit this.
Yeah, I can
So
see.
the
Yeah,
original
yeah.
design was a foldable, but with it,
Okay,
it's no longer
okay.
foldable.
Okay. That's fine.
I think
Uh-huh.
with
So
the
now it's no
real,
longer.
okay.
In fact, okay, my boss is here, so let him add more. This.
I think
Okay.
as John was saying, with the reinforcement that has been done at the back, the alteration, it has kindly made it not foldable.
Not
I think those are
foldable.
some of the
Okay,
few
okay.
challenges we are having on it, but it's
Right.
looking at the benefits we
Okay.
are gaining, the
I just
folding.
wanted I just wanted that clarification. That's okay.
Okay.
It's fine. It's fine.
We'll choose to use the folding and get it working than for us to not get
Okay,
it working at all.
it's working. That's the most important thing.
Yeah.
Yeah. Okay, let's go ahead.
No more questions? That's we're getting very close to the top of the hour, so maybe it's time to adjourn for this week and encourage other people who have can think of topics they would like to present. This was a great example of adapting technologies to the local environment. And thank you so much, John, for taking the effort of putting that presentation together. Great work.
Sure.